All right, in this video, we're going to start talking about quadratics, how to graph them, their properties. So, I'm going to start by looking at something we've been talking about, and that is graphing things using transformations. So, for our first example, f of x is equal to parentheses x minus 2 squared minus 3. Okay, so to graph this using transformations, we first noticed that our parent function is y equals x squared. Okay, and then we know that we have a horizontal shift of 2 to the right. And then 2, we have a vertical shift down 3 because of the minus 3. All right, so if we're going to graph that, we are going to take all of our regular standard points, and you can do this in the table just like we did before. The standard graph is x squared, so those points are negative 1, 1, 0, 0, and 1, 1. And we're going to transform them by going 2 to the right, so that would be what, x plus 2, and shifting down 3, so that would be the y minus 3. Okay, so our new graph, this f of x, is add 2, you get 1. Subtract 3, you get negative 2. Here you add 2, subtract 3. And once again, 1 plus 2, 3. 1 minus 3, negative 2. So our graph is at 1, negative 2, 2, negative 3, and 3, negative 2. Ooh, give it that parabolic shape. Ooh, do better than me. And we can see that it was pretty easy to graph this just with a shift and a shift. So we're just moving the entire graph over and down. All right, let's do another example. We have f of x is equal to 2 times x plus 3 squared plus 1. Okay, so looking at this in transformations, this 2 tells us that is a vertical stretch by 2. The x plus 3 tells us that is a horizontal shift, and that would be left 3. And then the plus 1 at the end tells us that's a vertical shift, up 1. Okay, so remember when we were doing transformations, we then went ahead and said, well, this would be in the y's, this would be in the x's, this would be in the y's. So with the x's, we're going to do x minus 3. And with the y's, we're going to do 2y plus 1. Okay, so we're going to do these two things to our standard graph. So rather than writing the original points again, x squared points, I'll just write the new points. So using the original negative 1, 1, I'm going to go to negative 4, and then the y's, that's 2 plus 1, 3. Okay, and then the next point would be the 0, 0. So put that in, you get negative 3, 1. And the third point from 1, 1, 1 minus 3 is negative 2. And then 2 times 1 plus 1 is 3. So when we graph this one, we're going to negative 4, 3. Then we're going to negative 3, 1. And then to negative 2, 3. So we can see that this created a vertical stretch. Our parabola is taller, and it is also shifted. Okay, so this is actually an easy way to graph parabolas or quadratics, and I think that ties it into what we were talking about before with transformations. And that form of the equation actually has a name. So that is called vertex form of a quadratic. So we're going to write out that vertex form here. So that would be f of x is equal to a times x minus h squared plus k. Okay, so there's a lot of letters in there because this is just the equation, but the hk is the vertex of the parabola. So the vertex being that minimum of the parabola or the maximum. And then the a value is the vertical stretch or shrink. And then for every parabola, we also have what's called an axis of symmetry. So the axis of symmetry is always going to be the equation x equals, and it's always going to be the h coordinate of the vertex. So the axis of symmetry there, x equals h. The vertex is h comma k, and then the equation in vertex form is right here. And we're going to want to put our equations in this form to be able to graph them easily by hand. All right, we also have what's called standard form of the equation. So standard form of a quadratic is f of x equals ax squared plus bx plus c. Okay, this is actually the typical form you've probably seen a lot before. The a, b, and c are numbers, they're coefficients. The a is the same as in the other equation, right? The a is still the vertical stretch or shrink. But hopefully you could, vertical stretch or shrink. But hopefully you can see h and k, the vertex, is not easily seen in this equation. The b is just a coefficient of x, which affects the equation. The c is the constant. And so the c is the constant, but it is also the y-intercept of a quadratic because it happens when x is equal to 0. All right. In our next video, we'll look at how to graph equations if they are in standard form.